Kiro? What is Kiro? Kiro is your new favorite coding assistant. It's the answer to the question, what if an idea could use all of the best AI features? It helps you, the developer, stay in the driving seat while doing your best work. And it does that with things such as natural language, spec-driven development, agentic hooks, multimodal models, and MCP servers to boot. It helps you build applications, projects, no matter the size and complexity. I have an exciting guest here today. Today I'm here with Marc, who's going to be teaching me and you all about what he likes to call, and I think everybody likes to call, the future of software development. So Marc is going to talk to me all about these new ways we approach software development with coding assistants, how you can get the best out of it, how not to get lost of it, how to retain control, a lot of those things. Before we kick it off, Marc, tell them, who are you? What do you do?
Yeah, hi, I'm Marc Brooker. I'm a VP and Distinguished Engineer here at Amazon. I've been at AWS for 17 years and building software the whole time. And before that, I built software for a living, and so I've been building software for a living for about 25 years. And, it is something that I love. It's something that I really enjoy, but it's something that also frustrates me, and I want it to be easier, and I want it to be more powerful, and I want it to be faster. And so I'm just really excited about, these new trends in software development that can, allow us as software developers to build things, more quickly, more reliably, build better software, build faster software, be more responsive to our users and customers.
And it's been a big shift, right? Especially in the last few years with the advent of generative AI assistants, like how people build software, who can build software has changed, right? So, can you walk to me are there some limitations when we talk about the current way of step-by-step programming? When people do build a thing, you basically use code to explain your application how to do stuff exactly. What's the limitation of that compared to something we want to do a little bit forward?
Yeah, so I think the biggest limitation of that is that there is a huge amount of detail that you need to put in there that isn't specific to the problem that you're trying to solve, right? It's all of this implementation stuff. It's understanding frameworks, understanding libraries, quirks of whichever language you're building with, quirks of whichever environment you're building with, whether it's the web or desktop or web services. And there's just so much to understand beyond what's really important, which is this problem that you're trying to solve by building a piece of software, this problem that your customers are wanting you to solve. And that has two effects. One of them is it means that, software developers spend a huge amount of their time on the things that are really kind of undifferentiated, not particularly interesting to them, not particularly interesting to their businesses or their customers. And the other is that it limits the set of people who can build software, the set of people who can be developers, because you just need this huge amount of context and huge amount of knowledge to even get started. And so I think if we can bring down that amount of knowledge, we can bring down the amount of work, we can bring down the amount of undifferentiated work, we can make software development much easier for a start, much more focused on solving the needs of customers, much more focused on the business outcome, much more focused on those data structures and algorithms, much more focused on the systems we want to build, whatever axis of development really excites us, and much less focused on all of those nitty-gritty implementation details, which, let's face it, today are important, but almost feel like they shouldn't be.
You need the skills to be a software developer. You need to be able to understand what's happening. You need to know all of that. The problem that you're running into is the vast amount of information. How many JavaScript frameworks are there out there, right?
Yeah.
One every day. We just probably
Thousands
have
of new ones.
Yeah, there's been two since we started talking. But back in my day, I could all the knowledge I needed for 6502 assembly was in a single book, and that's all the thing I needed to know to be able to write good software. Today, that's not the case. So having something like this definitely helps. You mentioned to me something called spec-driven development, specification-driven development. What is that, and why does that matter these days?
Yeah, so if we go, way back in history to the ways that people were, thinking about building software at the beginning of computing, people started off by building circuits. It was very sort of like E discipline of, turn this AND gate on and this one off and, those sorts of things. And then it went up to, we're going to write machine code, we're going to write assembly code, we're going to write these instructions for the processors and tell it, kind of step by step, get this address of memory and put it here, do this computation, put it there. And then there was this revolution in the 1950s and 60s of higher level programming languages. Things like COBOL came in. These visionary folks who saw that there were ways to raise the abstraction of programming. And, that trend has continued. We've seen COBOL give way to C and C++, and then Python and JavaScript. And, the language that folks are using today are even higher level. But they are still, for the most part, these imperative, step-by-step type, take this address in the array, add it to that address, move it here, move this pointer, type languages. And there are a few that have been very successful that are another form of language where you say, here are the things that I want the computer to do for me, right? Here are the things I want the computer to achieve. And how do you do that? Well, the computer can figure that out because computers are good at figuring that sort of thing out. And so if you look at something like SQL, it's very much that type of language. You say, here are the columns I want, here are the math, right? Go off and figure this out. Look over all of those data structures you have. Look over this database you have. Put these things together. Figure out join order and all of this other stuff. And so in some sense, that's a kind of specification. It's a specification for the data I want to get out of the database. Now, could we bring those sort of concepts of declaring what I want, saying what I want out of the program, and say, instead of saying how to do it, into a broader range of programming? Now, obviously, there have been a ton of attempts to do that over the 50 plus years of programming languages to bring sort of declaration. But this generation of AI tools has brought that so much closer and has made that, firstly, much more accessible, much more powerful, and much more flexible in the ways that we declare those things. And so we can get into the details of, how we declare and what is a specification. But the bottom line is, what I want to do is I want to say, here are the things my program should do. Here are the things I care about in terms of outcomes for my business, for my customer, for the efficiency of the program, all of these things, and then have all of the lower level implementation details figured out for me.
This sounds incredibly similar to like how we approached infrastructure building, right? Provisioning infrastructure on the cloud. We switched to infrastructure as code, which is a very much a declarative way of doing stuff. I need a database. You figure it out, right? So in essence, what you're talking about here is you're declaring what you want your application to do, and then letting an LLM, letting an agent kind of figure it out. So here's a hot take. An LLM is your compiler then? Some really weird abstract compiler, but sure, okay, that makes sense.
I think I get in trouble for saying it is a compiler, but that's the role that it's doing, right? It is taking a high level of description and adding in all of those implementation details. The other day I was writing, and I do a lot of kind of simulation work, mathematical work as part of my job, and I wrote a simulator in Python. Because I always choose Python for those sorts of things. It's fast to get going. And my simulator took about 5 minutes to run on my laptop. And I was getting frustrated with that. It's too much time. And so I asked Kiro to translate that Python code into Rust, build the Rust and run the Rust, end-to-end, including the translation, including the compilation and running, 48 seconds.
That's a great way to kind of optimize stuff. And like I have this like little lukewarm take I like to talk to people in these days. With the advent of like tools like Kiro, with spec-driven development, with coding assistants, there's absolutely no reason for you not to use Rust these days, because you have all the things to help you out there, people. You should try it out. I love that. Now, so one of the things that kind of stands out to me when you talk about spec-driven development, and this is in contrast to what people call these days vibe coding, right? What specific problems does spec-driven development solve compared to vibe coding, right? Vibe coding is fun, it's great, it's all help us explore, but there are problems. So what do you think? What do you feel like or think that spec-driven development solves here?
When I think about vibe coding, I'm thinking about giving the LLM a description of my program, but kind of step by step, very contextual, incomplete, based on the other things that it's done, based on other things I've seen, based on my mood, right? It's the sort of step by step of instructions. It's like teaching somebody to cook, sitting in a different room, kind of shouting sort of step by step, now turn on the stove. And despite all of those challenges, it works really well. But the things that don't work well is it tends to lose context, right? And so you'll be telling it to do something, and then 5 steps later, it'll undo one of those previous things you're doing. It tends to lose the bigger picture. You'll want to think about the architecture of your software, how the components go together in big ways. And, vibe coding tends to lose those things over time. Those APIs tend to get more complicated. Um, and as a human, it's very easy to lose the flow of what I'm trying to do, what I'm trying to express. It's very easy to forget about some of the requirements that are in my head or the requirements that have come from my customers. And what's great about spec-driven development is it gives me, as a human, building that piece of software, that bigger picture of here's everything. And I can go through that and I can think about it saying, is this everything? Is this everything I need to know? And then it gives the LLM that bigger picture of here's everything. And as I add to that, as I iterate on that, I don't lose the things that mattered to me before. And so I can take out a requirement if I no longer care about it, but I can keep reminding the LLM to say, well, yes, I still care about all of these other things. There's no sort of recency bias in there. And so it's just a more holistic way of thinking about partnering with the LLM, working with the LLM, working with other tools to build software together.
Yeah, and we'll throw up an example of how a spec file looks like. It's not incredibly rigid, but uses like user stories. That's usually kind of a very common way. As a user, I want to be able to log in and do stuff, right? But it is for me what I feel like the biggest problem it solves is the fact that it gives me control, right? Vibe coding is great, but like as you said, all of a sudden I don't know what happens. Made a bunch of changes, and I'm like, are we still doing the thing that I thought initially? I don't know. With spec-driven development, I feel like having this centralized source of truth, right? Here's what you should be looking at when building this thing out, makes me feel a lot more in control. And like, I feel like, the coding yourself into a corner is a lot more harder than just like with traditional vibe coding. And and this reminds me of something like, spec-driven. You start with a spec, right? Start this big old markdown file. Um, does that look like something we do at Amazon? We have this, we love to say stuff that we do here, working backwards, right? Is that kind of a similar approach? There's like, do you think that kind of influence our need to build this thing into Kiro?
Yeah, I think so. So since the earliest days of Amazon, we've had this idea, this culture of starting especially our technology products, but all our products from backwards from the customer. So starting by writing that press release, starting by writing that FAQ, starting by writing those documents of how should our customers experience this? What do we want them to say about this? What do we want the customer outcome to be? And what's been great about that is then it provides that uh, artifact for us all to look at and keep reminding ourselves about the path that we're on, right? Like, why are we building it this way? Well, because we decided that these are the right thing to do for our customers. It forces this customer backward, customer focused way of thinking rather than a technology forward way of thinking. And so I think that has influenced our design of Kiro in thinking about specifications, thinking about, well, I've got these problems I want to solve for my customer. I've got this thing that I want the program to do. And, let's write that down and then, yes, use that and keep referring back to that as we build instead of just sort of walking around, kind of exploring the space, maybe, and then losing sight of where we really want to end up.
I love it. It's a very good description of what our destination needs to be. The same goes for Amazon when we build products, but also same goes for you folks when you build software through your spec thing. I love that. Now, I think you mentioned here it's a partnership with AI when you're doing these things. What do you think? What's the line where I, as an engineer, and AI as my coding assistant, as Kiro, what's the line? How much I should write the spec versus how much Kiro should be writing the spec or building the spec? Like, should I do it all by myself, or should I just kind of hint stuff at the AI assistant? How do you approach these things?
Yeah, I think we're going to figure that out over time. I don't think we've quite figured out what the right balance is there, what exactly the right patterns are. But what I like to do there is I like to actually start off with vibe coding,
Okay.
start off with, let's create the basic outline of the program together, 2 or 3 prompts and get it going. And then extract the first version of the spec. And then I can start thinking about, okay, is this the right spec? Are we going in the right way? I can add requirements to that. I can remove things that were incorrectly inferred as requirements. And then really start iterating on that spec alongside Kiro, alongside the LLM, to do that development task. And so that's what I found to be effective for the kinds of programs I build. I think there are other kinds of programs that folks are going to, really want to start with a spec at the beginning, maybe something working with a product manager or working with somebody, working directly with customers, working directly with stakeholders to build those specs. And then there are cases where, maybe late in the development process, you've been vibe coding, working with AI tools, you realize that you have done that kind of code yourself into a corner thing, and then you can jump up to the level of specification, undo the bits of that aren't working without recreating everything from the beginning. And so I think they're going to be valuable patterns that start with specification almost at every step of software development.
See, that's a good point, right? When folks go out there and build stuff with Cure, like a brand new project, it makes perfect sense for me to how to start with a spec, right? I'll build this file, there's a template, or I'll ask it to do stuff for me. How would you recommend me and them to? I have an existing project. I have this thing. I have this big old source of spec debt. How do I tackle that thing? It had no specs, right? It had no specifications. What would be the approach for you to take to to grasp an existing project? Do you write it yourself, or how would you approach that?
One of the things that I, really like LLM tools for is exploring code bases, exploring schemas, explain to me what this file does. Often there's, especially in older code bases, you find these files that have no comments or very out of date comments, completely, complicated code. And I've found that LLMs do a great job of, explaining this to me. And then often the next step is a step that has been, the classic approach to refactoring software is let's put in an API, let's separate this out into a different component, a different library, maybe a different microservice, depending on how you want your architecture to be. And now you've got this more self-contained unit that then you can start creating that specification for. And that will allow you to then refactor that unit, maybe translate it to a different language, maybe rewrite the piece of code that aren't working, maybe focus on performance in Rust. Yeah, all of those things. And it really is that exploration is super powered. And then once you've explored, once you've found those kind of natural splits in the code base, then you can start applying specification to each part of the code base. And that allows you to iterate quickly on those without changing the API contracts, which is a really powerful way to do refactoring. And, has been the classic way correctly to do refactoring for a long time.
And this is a very important point, right? You shouldn't just take a big old monolith and just hope for it hope for the best by creating a spec. You should definitely, what's the called, strangle pattern, when you start like extracting microservices from it and doing great. So don't try to write the specs for the whole code base. It won't work. Excellent. Now, you told me you built this example, and we're gonna read it in your blog post as well, about building the Tower of Hanoi game. How did you approach that? Like, what was your path to like building that from scratch using this specification?
Yeah, so just start the story off. There's been a lot of buzz recently about, can LLMs play these simple games like Towers of Hanoi? And maybe they can, maybe they can't, but very clearly augmented by having the ability to run code, they can write code that can play those games, which I think is a really important point. Um, then, I'm not a web developer. I come from a service building background. I built some databases. I built these low-level storage systems. I'm much more comfortable moving bits and bytes around than I am moving pixels around. And so, when I approach web development, uh, it's really great to be able to start off with that, build me a website, use a modern framework, use modern TypeScript, use modern approaches to build this website for me. And now we've got the framework together, and it's much easier for me as somebody who's not deep in those tools to then modify that and improve it rather than start from scratch. So that's kind of step one. And so that development started off with, again, a couple of prompts of, hey, build me this Tower of Hanoi game. I want these patterns. I want it to be able to do these things. Um, and then, okay, I've got the specification for that. Let's then go through the requirements. Let's pick which libraries we're going to use. Let's pick which frameworks we're going to use. Hey, I want it to be a game that I can play in my browser rather than in the desktop. And so go from specification to those requirements. And then, well, let's go and write the code now. And Kiro wrote all of the code for the first version based on that, based on the requirements that we'd been working on together, based on the spec that we'd been working on together. I opened it up in the browser. You know, great little game. I can click around, I can play the game, but there are a couple of things that don't quite work. And there are a couple of things that don't quite work because the specification wasn't quite precise enough. And there were a couple of things that don't quite work because I just forgot to mention them in the specification. So as I say in the blog post, I added "oh, I'm stuck, solve this for me" button.
Yeah.
Super, super useful if you're playing any kind of game. But instead of solving it from where I was, it reset the game and solved it from the beginning.
Okay.
Right.
Well, there you go. Okay.
And going back to the specification, it was easy to see why the LLM had implemented it that way, because that's what I asked for. And with a couple of lines of change or even a couple of words of change to the specification, I could say to Kiro, okay, now go and fix this problem with the code. It did the little bit of refactoring in the code. It fixed the logic bug. It changed the way that it tracked the state of the game to be able to pass it into the sort of game playing AI, I guess, and then fix that bug. And so that's the kind of iteration journey, is going back to the specification, making it more clear, maybe adding or removing requirements, and then ending up with a game that is, somewhat as fun as Towers of Hanoi can ever be to play.
True, true, true. It's kind of a fascinating little practice we are gonna try to call back because a lot of us, the vibe coders, or like just even developers in the last 10 years, we just kind of go ahead and just do stuff, right? Especially individual developers, you just have an idea and you just go and build it without actually giving it a lot of thought. So implementing a practice that you are going to sit down, write a little, here's what I want it to be, actually gives you a moment for pause, a moment for understand, like, here's what I exactly want my application to do, and you can potentially identify problems. The same we do, like working backwards. You write this PRFAQ, and then like everybody grills you on it, like, oh, what about this? What about that? I feel like that's kind of a great practice just for building, not writing quality software, but building quality, resistant, resilient, whatever you want to call systems. So love that, love that. Now, for folks out there, right? Like you mentioned, like this whole, we've started adding levels of abstraction, right? From punch cards, well, from electronics, punch cards, machine assembly, yada yada yada. All of a sudden, another layer of abstraction. How can you convince me, well, them, why should these people go ahead and adopt a tool like Hero that uses spec-driven development? How can you convince the developers that the specifications, will not slow them down?
Yeah. So, I think throughout the history of computing, we have been adding these abstractions. And there have always been reasons that we want to punch through the abstractions. There's always been a huge amount of, value in the skill of being able to see through multiple layers of the stack. But despite that, on average, those abstractions have been a huge win. If you look at how productive it is to write a piece of software in TypeScript or in Rust,
Right.
rather than in assemblies, or by flicking the switches on the front of a machine. Those abstractions have been a huge net win. Not perfect, not entirely, not leaky, but a huge net win. And so I think this one is going to play out the same way. I think there are going to be cases where the abstraction isn't perfect. We're going to need to look below it. I think that skill of being able to look through multiple layers of abstraction is going to remain a super valuable one for some software engineers. But I think for the vast majority of developers, what we're going to see is this added layer of abstraction means faster software development. It means software development that's closer to the user, closer to the requirements, closer to the outcome that we want. And that means more time focusing on what's important. And if what's important is, adding features, more time doing that. If what's important is improving performance, reducing footprint, improving efficiency, that means more time doing that. If what's important means moving from a old stack into a new stack, or adopting a new database, adopting the cloud, then it means more time being able to do that. And so these abstractions, I think, throughout the history of computing have allowed us to spend more of our time, not all of our time, but more of our time focusing on what's really important and what's really valuable in the task that we're doing as software developers. And I think that's the way that I've seen AI play out as a developer already. And I think specification-driven development is the next logical step in that journey.
Any amount of time you would lose in like writing those specifications and like kind of initial thing, you will gain as it goes on build stuff instead of just kind of the Wild West stuff going. I like that. Okay, nice, nice. And like, I agree. And I think even like when it comes to this level of abstractions, I think this level of abstraction is a lot more safer than the previous level of abstraction. When we all like started like just writing willy-nilly Python and JavaScript, there was a lot of people who knew how to code, but they just like adopted any old framework out there, and it was not the best, not most optimized, but that was the most used, and it was just kind of like you were hoping for the best. At least LLMs have the reasoning to understand what's an optimal way to write some Python, what's the optimal way to write some JavaScript, or just use Rust. Uh, but excellent. So I think for a wrap up there, for folks out there who are going to go ahead and use Kiro, people who are going to go ahead and write their first spec, can you give me or them, or just give us a suggestion of what projects work really well with this kind of an approach? I mean, I know everything is kind of probably going to be the answer, but give us a challenge, give us something to do.
Wow, yeah, that's, I mean, I often, build these little games. I'm again, not much of a game developer, but I have these things in my head. I like to do these things with my kids sometimes of, kids are super creative. These natural born product managers. And have games in their heads and just want to bring them into the world. And that's a super fun place to start. Another thing that I've been doing a lot is I do a lot of, a lot of kind of simulation work, a lot of, statistical and data processing work. It's turned out to be really great at that. And so these questions of, I have a big chunk of data, I have these things I want to figure out from it, but I don't necessarily know the right approaches, or I don't know the right tools to do that. I found that, these kinds of LLM-powered tools have been super useful for that. And then the other tool that I, have been using a lot is one that I built very quickly with Kiro a couple of weeks ago, is a very lightweight sort of database administration tool. So we launched Aurora DSQL last year, and that's there's a lot that I want to test out in that. I want to try new features that the team is building, and I want to work with that. And so I built this little tool where I can say in natural language, create me a table, add some test data, create a transaction of this kind. Let's try out that feature. Let's go hunting for a bug. And, that was a tool that not only was built with Kiro, but also uses an LLM to do that text to SQL translation. And so that's really fun, is that you can sort of use LLMs to build software that uses LLMs to do things. You can call those programs agents or not, as you choose.
Of course.
But that's also super cool. And being able to say, I wish I had a command line tool, or I wish I had a little tool that did this thing. Now you can bring those things into being in minutes.
That's so beautiful. Again, building your own tools, like making the AI be your assistant, but also help you build those tools to be a lot more productive is great. So folks, go ahead, push those pixels on those screens, build those tools, do some simulations, write the Linux device driver. I don't know, like, yes, in Rust, sure. But definitely go ahead and check out Kiro. We're gonna leave the links to Marc's blog post, as well to the place where you can go ahead and try and play with Kiro, and let us know in the comments, what is the thing you want to go ahead and build first. I want to see your spec files. If you like this content, there's a little subscribe button below us. If you like today's video, there's a like button. We'll see you all in the next video. I need to show Marc some of my Rust DSQL code here, so